All right, good morning and welcome to Astronomy and Coffee, where I have some coffee and we're going to talk about what is going on in our nighttime sky tonight, this Monday the 31st, a very special day in American history. Why? Well, because today is my birthday. Yes, where I turned 25 again. Now, not only is it my birthday, but also the birthday of Harry Potter, J.K. Rowling, who else here? Dean Cain, Superman, Wesley Snipes, Blade, Mark Cuban, BJ Novak, and Michael Biehn from the Terminator series. So, happy birthday to all of them, and possibly to you if today is also your birthday. But we're not here to talk about birthdays. We are here to talk about what is going on in our nighttime sky. And what we have coming up today is going to be a look at Venus and how it looks kind of interesting if you can spot it in the sky, and how it looks a little bit different. Also, there is a James Webb discovery of water vapor around a rocky planet-forming zone, and also another, let's see who discovered this. Was it Hubble? Yes, Hubble discovered this planet that appears to be having the hiccups. So we're going to learn a little bit about that. So first off, let's take a look over here at the nighttime sky. I need to reverse time a little bit here. Okay. So there's the south, east, the west. And we're going to bring up some constellation lines because you'll see this little figure here, this little backwards J shape, this little fish hook in the sky here. And then if you can find this, you have found Scorpius the Scorpion. Now that is not the only thing we can find in our nighttime sky. Let me see if I can get rid of the moon here. That doesn't matter. Well, this is the moon. Let's take a look at the moon real quick. Let me see what phase we're in here. Okay. So yeah, almost a full moon. Getting really close to a full moon here. But that's not important. What is important is this teapot shape. So this will be quite easy to find tonight. If you can see this little teapot shape here, see these little lines that form the lid of the teapot, the spout of the teapot, the handle of the teapot. Well, that is going to be Sagittarius the Archer. And Sagittarius will appear to be aiming his arrow at this scorpion, which is going to be Scorpius the Scorpion. There's Scorpius the Scorpion right there. And then here you can see Sagittarius the centaur-like archer. I wanted to say author. He could be an author, but anyways, he is aiming his arrow at Scorpius the Scorpion. So those are two constellations you can easily find for yourself this evening. So right on the southern horizon, right towards the southwest, look for this sort of winding, almost like a question mark or J shape or fish hook shape in the sky. That is Scorpius the Scorpion. And then find that little teapot. And if you're having trouble finding it, you can easily find it from the moon right there. But now, we want to talk a little bit about that James Webb discovery of the water vapor in this rocky planet-forming zone. Let's go over here to... Now, this isn't a planet. This is something else here. But, so one question that scientists have been trying to tackle is how Earth got its water. Now, some insight might be gained by looking at this star PDS 70 and its two gas giants. So PDS 70 we're going to go to right now, and as far as we know, it has these two gas giants, and there's this rocky planet-forming region therein. Now, this star is around 370 light years away, and it also hosts these two gas giants here. You'll see gas giants here. PDS 70 B and C. The star is usually named A. It's always named A. But these are both in within the inner disk, and then there's the outer disk of gas and dust with a 5 billion wide mile gap in between. Now, within that inner disk is this water vapor around 100 million miles from the star. So this is the first detection of water in the terrestrial region of a disk already known to host two or more protoplanets. So this is pretty exciting because this is the region of space from a star where planets like the Earth usually form. Now, scientists haven't discovered planets being formed yet in this region, but the raw materials are there. So they think that if planets do form in this region, they will have water available to them from the beginning. Well, I mentioned a second ago that we're going to be looking at Venus a little bit because it looks a little bit different right now. Well, it looks a little bit different than what you would normally recognize it for. So let's go back over here to Stellarium and reverse time a tad. Okay, there's Venus. So right after the sun sets, you will find Venus. So I'm going to zoom in on Venus here, so we can take a look at what this little guy looks like. And once we zoom in, we will see, let's pause it. We will see this. Now, this crescent shape that you are seeing here with Venus is pretty interesting. Well, this is what is the result of when Venus is in inferior conjunction. So Venus orbits the sun interior to the Earth. Now, from our perspective, we are seeing it as it appears between the Earth and the sun. Now, at superior conjunction, it will appear on the far side of its orbit. So currently, it's known as the evening star because the sun is setting, and as the sun sets, you will then see Venus. But when Venus starts passing to the right side of the sun, it will be known as the morning star because you'll be able to see it around the morning time. Well, let's get out of this here now. So, as the sun sets, take a look at Venus and try to see if you can find that little crescent shape to Venus right there. Okay, well, I've just mentioned that the Hubble Space Telescope has witnessed or has seen a planet that appears to be hiccuping. Let's go over here and take a look at this planet real quick. Take a look here. Well, this is a young planet whirling around this red star, and it's changing in what's going on here by orbit. And this is because there is this consistent torrential blast of energy that evaporates the hydrogen atmosphere of this particular planet, causing it to puff off the planet. Now, NASA has prepared for us this nice little video here, so I'm going to go ahead and play that video for you and let them explain why this planet appears to have hiccups. So roll that beautiful beam footage.
A young planet whirling closely around a red dwarf star is changing in unpredictable ways with each orbit. NASA's Hubble Space Telescope observations initially showed the planet wasn't losing its atmosphere to its parent star. 1.5 years later, Hubble observations revealed clear signs that the star's torrential blasts of energy, called a stellar wind, were stripping the planet's hydrogen atmosphere. These extreme changes between orbits, and over such a short period of time, shocked astronomers. Red dwarfs are the most abundant stars in our Milky Way galaxy, and they likely host most of our galaxy's planets. But can these planets be hospitable to life? These new Hubble results suggest that this particular red dwarf may have sudden and extremely variable outbursts. Under these intense conditions, planets forming within the first 100 million years of the red dwarf star's birth should experience the greatest loss of their atmosphere, possibly stripping it away completely. One possible explanation for the vastly different Hubble observations is that the torrential stellar wind shapes the planet's atmospheric loss, sometimes making it observable and at other times not. It may even cause some of the outflow to hiccup out ahead of the planet itself. Stellar models predict this hiccup, but Hubble provided the first observational evidence of it happening, and to an extreme degree. Thanks to Hubble, we're learning more about how planets form and survive around stars very different from our own, helping us uncover the mysteries of the universe.
And with that, we have another episode of Astronomy and Coffee. I hope you are having a wonderful day so far on this Work Monday here. And as we settle in for work, I think you know a couple of interesting things now about your nighttime sky. And enjoy the rest of your coffee. Enjoy the rest of your day. And I will see you next week with what is going on up in space and possibly on Earth. I don't know. We'll see. And until then, see you around.